All right, I can start.
Yeah, please. Thank you. Actually, I was wondering if real quick, I know that I think most of us know each other, but I wanted to start making it a practice for these meetings to just go around the room and introduce ourselves really quickly, just super brief, so that we know who everyone is. So for me, I'm Emerson Knapp. I work at AWS right now on the RoboMaker team, and so that's really all I wanted to just get for everyone is like a real quick like, where are you coming from? And I'm in California, so maybe we'll go next to Jesse.
Same with Emerson. I work on the AWS team. Just joined a few months ago, and also in California.
Great. Adam, how about you?
All right, so my name is Adam Dabrowski, and I'm calling in from around Warsaw. Normally, I'm in Warsaw, Poland, and I am from Robotech.
Great. Christoph? If you're there. If not, maybe we'll just go to Dirk.
Yeah, I'm Dirk Thomas. I work at Open Robotics, so I'm basically focused on ROS2 all the time.
Great. Last up, Karsten.
Hi, Carsten, work at Bosch, also mainly focusing on ROS2.
Great. Thanks, guys. I know it's especially a small group today, so we could get through it quick, but occasionally in the meetings, I see names I'm not familiar with, so I wanted to make sure that everyone feels sort of welcome at the table. Oh, and then we just got Aaron on the line. I don't know if you're actually there, Aaron.
I am so here. Yeah, Aaron Brazil, AWS, run the team that Jesse and Emerson are on, and it looks like Devin's shown up as well. So that's great. Really looking forward to what we can do here.
Cool. Yeah, Devin Bonnie is also on our team. Hey, Devin, we were just introducing ourselves real quick, but he's in California with us. So I think that's everyone. And Adam, if you want to take us away and talk to us about performance, I think we can get going.
All right. So, Dayan is just joining right in time.
Great.
Hi, Dayan.
Hi, Dayan.
I was about to start.
Perfect.
Yeah, great timing. Some of you, I mean, like in the audience, there are people that know the topic very well, like Dayan and Carsten, and people who were on the tooling call, and also some people I assume that don't know much about the subject yet. So I will start with some general introduction. Just stop me if that's too basic. Rosbag2 performance isn't very good at the moment. We had several issues raised, and one article which gained some publicity indicating that especially with recording part, the performance isn't really good. So it's quite weaker than ROS1 performance. And the effect of this lower performance is that some messages get lost. This is because we have message queues, and we have everything processed from receiving the message to recording it, to writing it to the disk in the SQLite database, which is the default plugin. We have everything in one thread, so we do need to wait for a successful write to this database in order to process next message in this callback queue. And Rosbag2 doesn't manage to make it quick enough in some cases. So if the throughput is large enough, we do have this situation where the message queue is full when messages are coming. So we lose messages. And this can be pretty serious. I will show some stats. Perhaps now it would be best to share the screen. can you see my screen now?
Yes.
Okay, great. So what you are seeing is not a presentation, so it's not not slides. I didn't prepare slides especially for this call, but it's a report which we can go through, and basically I will talk over it, and then we can publish that. I will publish that so everybody can read more in detail. This is a part of work that is already has presence on GitHub, of course. You can check the pull request, which passed the automatic checks but is awaiting review. This is our pull request number 442. So you can navigate there, and a meta ticket for performance packages and testing of performance is ticket number 435. So these two basically have all the links to issues that come out from this performance testing and some results. And also there I will attach this report after the call. All right, so in this pull request, there are some packages that we used to benchmark the performance. So, and not only the state of the current code performance, so not only what is currently on master, but also with some changes to explore, the theories about how certain changes in implementation affect performance. So we already have results for those changes. These are not implemented yet, but there are 3 issues linked to this meta ticket that suggest implementation, and and I hope have enough information in the description to allow implementation of those fixes. So our results here from this change code base are based on a hacky code, just to understand how it affects performance. So I didn't really fix that yet. But all the results that I will be presenting here can be recreated by using those packages. So there's everything in this pull request. Everybody is hearing me, right? Just a quick check.
Yes.
Okay, good. Yeah, so of course you can check this pull request whenever you want. As I mentioned, there are 3 performance issues that we identified, which seem to be the most important ones. So after fixing these, I suppose that a good idea is to check how the performance changed, of course, which I suppose should be in line with the results here, and also to investigate the performance issues again, because then we will get something more uncovered, and we can also test performance in scenarios that I didn't test. So of course, to test performance, you have to select a kind of approach. For several reasons, we choose to go to this Medium article where there was scores published for an earlier version of Rosbag2 with this kind of matrix, which you see the table here, exploring different scenarios. And we have 100 Hertz frequency on each topic, which is quite high, of course, but that's what all 4 choose. Number of topics 1, 10, 100, or 1000, and message size from 1 kilobyte to 1 megabyte. So already you can see that these are scenarios of very different throughputs, and throughputs for the write down, lower right part of the table are very high and something that most disks can't take. But it was still investigated because, of course, if Rosbags have very good performance, then they should be only limited by disk write speed and not something else. But it turns out it's not the case, and we have message loss, which is larger than expected by just a disk write limitation.
Yeah, that 0 messages is a surprising result. I feel like we would want to get at least something.
Yeah, at least you know some things that went into the buffer, into the callback queue. So since the methodology in this article is not very well described, I mean, the details are missing. We started by recreating this matrix, so this table, but using up-to-date version and of course with some clear methodology, which I hope is clear. You decide. So of course our expectation for performance is that it's only limited by disk write speed, and you know, you can always increase queue size. So use memory always in to let's say prolong the process, but have a bit more of performance, right? So of course, since I mentioned the disk write speed limitation, then here you have the specification of what was used to run all those benchmarks. In total, 768 tests were run on this platform. And yeah, we used this table, but also changed some parameters which are important for performance. So there is currently a max cache size parameter in Rosbag2, which with SQLite storage is basically a size of transaction. So if you have cache size parameter 1, then you have transaction for every write. And if you have 1,000, then you have 1,000 inserts in one transaction, so 1,000 messages. Also, there is a default value of 0, which SQLite with SQLite behaves the same as 1, basically, because with 0, the transaction is opened implicitly in SQLite. If there is no open transaction and an insert is attempted, then the transaction is opened. So, and of course, max cache size parameter is it's very important to understand it in relation to how many messages per second are there actually, because it should be adjusted to this value. We'll see that soon. A very important optimization is in SQLite settings. Currently, SQLite settings by default are in current master, journal mode memory and synchronous off. So these two settings are particularly important for performance. There are many more in SQLite, but these two are especially affect performance. Just in short, journal mode. Default are journal mode WAL, so it's write ahead logging, and synchronous on, normal. These two values, so memory and off, are optimization. So this basically tells the SQLite how to treat transaction, how to make sure that transactions, that the database is in consistent state, even if your application crashes or your operating system crashes. So at the cost of performance, and quite a lot of that, you can basically trade off between robustness and so crash resistance and performance. And here these values that we are currently using are I would suggest that they are more suited for databases that hold a very very important information, such as customer accounts or thing. And in case of recalling large amounts of data, we certainly want to be able to manipulate those. So there is an issue number 437, which I would say is the first issue to fix to improve the performance the most. We also did this benchmarking with and without transport to just focus on storage and also to capture everything. So 768 tests. Each cross product of those options was executed 3 times, so we get an average. And each time only 1,000 messages were sent. So that's a certain limitation of this test. But 1,000 messages per topic, so per publisher, not total. Okay, so I don't know if it's visible. There's a little schema which is not that important, but it's showing how I approached the transportless implementation. I wanted to simulate message loss, so I did introduce queues. There are producers of messages. This is without transport, right? So I have to simulate messages arriving somehow. Messages are produced by a number of producers, and of course the queues are being filled and consumed by sequential writer, which is the same writer that does write in the normal case in Rosbag2. And those queues, of course, have default size 10, default for the QoS. So if a message producer wants to write to a queue, but it's full, then I note that the message was lost. So that's basically how I counted message loss events, which then result in a percentage of how many messages we got in certain cases. And also there's a little visualization. I'm not sure if that's visible. There are dots and X's which just show the events of loss. So X is a loss, and
I can see that it's
you
there.
can sometimes get some.
I can see that it's there. Are you able to zoom in at all?
It's not.
Are you able to zoom in at all?
Yes. Yeah. So this is the output of a single benchmark. So of course, when you run 768 of them, then you need some processing, but you can also investigate certain cases when the messages are lost. And here you can see that if we have a larger cache size, then we kind of have this moment when we sync and we wait for the transaction to complete, which is a larger transaction, and then we lose messages, right? Mm-hmm. Even though the overall performance might be higher in terms of how many messages we received in the end, then we have a situation where we have the loss that in some situations might be considered worse because it's a continuous loss, right? Not every other frame, for example, which would be less impactful. Yeah, so you can always refer to sqlite.org to see to read the descriptions of how those settings affect certain situations. Basically, I believe if we do back splitting and our application doesn't crash normally, then those settings of memory and synchronous off are superior. So the issue number 437 is about empowering the user to choose those. So actually to being able to configure SQLite. Currently they're hard-coded in SQLite Writer. So so now we have results. I will just, yes?
Question about this. So are these configurations global for the whole usage of SQLite? Or is there a way that we could think about, which topics are more important to record than others? I'm not sure if you've looked into that.
They are database settings.
Okay, so it's not something you could tune on a per topic basis.
No, there is some. There are some tuning that you can do per topic differently, but mostly SQLite is quite simple. So you have settings, pragma level settings, which are for the entire database.
Okay.
So of course you can do things like record topics that you find very important in a separate file, so a separate database with different journal mode and synchronous. So that's always possible, right? You can have two files open, two databases. Yeah. So I will just go through that quickly because it's I think it's 16 pages here, and I would like to have some time for discussions as well. But when you look into this report after I published that, you can take your time and of course write to me whatever you noticed or whatever is interesting to you. But the structure is as you can see, cache size, transport, and SQLite optimization parameters are on the top, and then you have the matrix, and then some kind of plot, CPU and disk utilization. So disk utilization at times might be not very intuitive, but don't just look at size times topics times frequency, but also look how many messages actually got here, because those scenarios differ in how much time is spent to wait for certain events, like transaction to complete, to journal to check, to be written, and synchronous. So synchronization with, which means that we wait for an operating system to confirm that the data is actually written to the disk. So these events differ in scenarios. So I just skip. You will notice that in some on some every other page, basically, like with the versions with transport, you have CPU utilization and disk write utilization, but you don't have for cases. You don't have it for cases without transport. I decided it's not very important because we have a full case with transport, and these measures are more important in that case. But if you think otherwise, also let me know. Okay, so skipping to summary, just to save you comparing those tables and going through them yourself. I already hinted before what helps the most. And here are results with cache parameter 1, which is very much not optimal, but I will come back to that soon. So optimized and default are compared in the first table. Optimized means those two settings in SQLite have been changed. So journal mode is memory and synchronous is off. And you can see there are huge improvements in how many messages we got. What's also very important that once we have max cache size parameter high enough, which of course, as I said, depends on how many messages per second you're getting, then we get finally we get results which are which indicate that this is only limited by disk write speed. So this is 1 megabyte. I don't know, you can see my mouse cursor, right?
Yes.
On this presentation, yeah. So these cases where you have 60-something% are 1 gigabyte per second data. So as I showed before, we have 500-something megabytes per second disk. So it's expected that we don't get all the messages, but we get a bit more because of buffers. We have queues, we have cache size, right? So this amount of buffering helps us get even more than the disk limitation. And
so
we have 100.
Sorry, is this just based on the length of the test? If you ran the test for longer, would it average down to the 50% or whatever you're expecting based on your available disk write speed?
Yes, I believe so. I believe so. I haven't run this test yet. This is a very good follow-up step to run a test for long. One has to, of course, to take into consideration the size of the database. So, you know, this gets filled pretty quickly if you have 1 GB per second. But certainly, it's very interesting to see how this behaves over time. But here also, in case of 100 megabytes per second, we have 100%. So if we go back, yeah, that looks much better than here. So this is 100 megabyte because you have to multiply this through this and through times frequency. So previously we had very bad scores. But that's in the article, right? That's something that already improved just by changes that were made to Rosbags since this article was made, and also because probably the methodology was a bit different. But the difference is quite large. We do have 100% messages with 100 megabyte per second case. So this SQLite settings and a larger cache parameter together look very good for performance. So a note about the cache size. First, it should be dependent on how many messages you get per second. The implementation currently is not very optimal because we fill in this vector and then we only start writing when it's full. What would be better would be to open a transaction already and start writing and use this as a buffer. Perhaps then we should change the name, but that would be better for performance. Max cache parameter, max cache size parameter could also be, it should be possible to set it in terms of time as opposed to number of messages. So for example, 1 second of messages. That would be very good because this would allow us to have good behavior regardless of how many topics we get or how much traffic we get. And also currently we have one thread that processes the callback queue, so takes from the queue and writes the message to the SQLite. So this is the same thread, so we have this wait time for the operation to finish. If we had this in a producer-consumer scheme, that would also be better. But note that for this SQLite optimization, so if we have synchronous off, this effect is less powerful, of course. So we already get some performance increase, you know, from the same category. So from not waiting for write operation to complete. Yeah, and so conclusions are we have some priorities. We have some insight into priorities of if we want to increase performance of Rosbags, what to fix, in what order exactly. So, of course, please feel welcome to use this pull request to repeat the results or find something else and let me know. Yes, so here's just some remaining work. I think we can start a discussion right now because that's it. Here are some more suggestions. So I think situation with higher number of topics is worse. So, and there are transport losses as well, which we didn't benchmark. If the database gets large and there's a lot of messages, then I would also suggest exploring the effect of creating index after all the writes, because there is an overhead. If you create it before, That's not very optimal because you only do writes. You don't need to read the data in any kind of order. So it's with lots of messages, it's better to only create index in SQLite table after recording. And of course, another thing to investigate is page and cache size in SQLite. Cache size is a different thing than max cache size that I mentioned. Cache size means SQLite settings of how many pages to keep in the cache. So this there are some numbers on SQLite web pages which indicate that for different blob sizes. So if you expect your messages to be of certain size, then you can also improve performance some by modifying those settings. All right. So what are your comments and questions?
Did you happen to test compression at all?
No, I didn't yet. But I would expect compression to increase performance because the bottleneck is I/O, so input-output operations. But that's something to test. Compression is per message is ready in Rosbag, right?
Yeah,
this
we're
something that
finishing up the review. I think it's even improved now.
There was one downside. We did a little bit of work into it. The spoiler is because the writes are single-threaded. When you compress a file, you're waiting. There isn't currently a separate thread that's doing the compression while you're waiting for messages.
Which I think would be solved by the producer-consumer suggestion to spin that off into a separate thread as an architectural.
Yeah, exactly.
Yeah. So that sounds good. When I started doing this, compression wasn't ready compression per message yet, so I didn't measure that.
Sorry, I just lost my train of thought. Did you measure the CPU usage as well? I know that a lot of the bottleneck here for actually recording messages is the disk write speed, but a complaint that a lot of people I've worked with have in ROS1 Rosbag is that it is fairly wasteful for what they think is a simple recording operation. It uses a lot of CPU, so I'm wondering if we have metrics here such that we could at least compare those, because I'm trying to sell some people on ROS2 these days.
Yeah, we have some numbers here. However, we didn't pay a lot of attention to make sure that these results are proper. They are measured by system monitoring tools, but this is something. If you want to plot it and compare it to ROS1, that's perhaps the best idea is to take the packages and try several other tools to measure CPU utilization and make some nice plots. Here is just some numbers, but it's a good idea to start with the code. Just coming back to packages, this Rosbag2 benchmarking package is the one that you want to use when you benchmark the entire pipeline of Rosbag2, so including transport. And in these packages, those tools are being executed. So the CPU and input-output measurements. So writer benchmarking is just without transport. So these queues and producers to focus on storage.
Makes sense.
So
here, if we switch on the encryption, it's not going to help the CPU consumption.
Oh yes. So that's a trade-off. It's smaller on the disk and not as limited by I/O, so input-output, but at the cost of CPU, obviously.
Yeah. In this experiment, I know you're focusing here on how we can optimize the performance as it's currently implemented, but I'm wondering if you looked into any alternative storage formats that would be better optimized for writing, because I've been thinking about that a little bit, of having sort of a asymmetric Rosbag where you have a write optimized layer that you use when you're recording, and then you could convert that into something that's easier to play and inspect when you need to.
I mean, SQLite isn't as bad as some people think. I mean, when configured properly, but also, of course, it's not something to use when you want sharding and you know, all the features that advanced databases have, and not if your case is very high throughput. I mean, like in some well-known cases in automotive. So
Yes.
I didn't investigate competition, no time. So that's the entire thing I did is presented here. So
yeah,
yeah,
okay.
That's of
Just,
course that's great.
asking.
That's great to do. Yeah.
So you said something about creating the index offline. I assume that would save a CPU as well as your write performance if you did that after creating the database. Could you do that like well after the fact?
Yes. I didn't try that, but as a principle, of course, you can end a transaction with the final write and then reopen the database after, you know, 1 year or whatever, and then put an index on it. It's a create index operation you can do regardless of whether there is something there or not. But if there is something there, of course, that takes time and quite much. So my first approach to test that was to run one. I ran one test, one straight test, just to check how it looks like. And then there was a lot of messages, and I saw improvement, yes, but I can't tell you how much because it wasn't a proper benchmark. Just my, you know,
is that really,
just my exploration.
Is that very easy to enable that test without the index creation? I'm not that familiar with SQLite configuration myself, so that's why I ask.
Yeah, it's very easy. It's when you are creating the database. So when you are creating the table there, you currently in SQLwriter we have creation of index already before we start any insert, right? Mm-hmm. And instead, you can just check a certain parameter. In this issue, I actually included a patch, which I used to test. This patch enables you to read a hacky config file, and then if there is a creates index value there after, then it does create index after. So I tested this. And my behavior was because I only use Ubuntu. Then after Control-C, then I started creating the index, and it took a while. But also recording was prior was faster.
Okay. Yeah, so, I'd be interested in adding another test case to see how much faster. But that's something that we could extend the framework you put together here to do.
Yeah, so here suggested work is like the point 3, investigate B, effects of creating index after all writes.
Oh, yeah.
So I know it's important for, especially if you have lots of messages, a large database. So because I already explored, but I can't give you any numbers or, you know, that wouldn't be proper.
Yeah, this all looks really good. I feel like a lot of these suggestions are not that hard to implement, which means we could get some pretty good performance improvements with fairly minimal effort, which I'm excited about.
Yeah, I mean, especially you can already, like, if you have a huge need for getting it right now. I mean, in 5 minutes, literally in 5 minutes, then just change those hard-coded values to the ones I suggested and rebuild the package, right? And you will see already as performance improve. But also be worried that your database, so your Rosbag, can, if your application crashes and you are unlucky, or if your operating system crashes, then probably always it will be corrupted.
So that's the downside to the journal mode is that an unclean exit leads to a corrupted database. Is there any way to recover that, or?
One thing is that the effect of synchronous setting is much stronger than the journal mode. settings. So you can only do this one, and then you only have corruption if the operating system crashes, which, I would take it for increased performance.
Especially if you're splitting bags and therefore have a maximum amount of time that you lose.
Exactly. If you split bags and you have like 5 minutes of data in each, then yeah, it happens very rarely. That this kind of crash. And I think that's something that people would take without much thinking compared to, to how much performance gain this gets them.
Yeah,
Adam, one question regarding the index. When we say we can create the index afterward, I think what we do right now, if I remember correctly, and like I think the first time we wrote here was like 2017 or 18. We kind of like auto-generate the index. So we have like a whatever default index which goes through all the messages. I think like basically numbering line one by one.
There is index on timestamps.
Index the way you want. Is there a way that it actually makes sense to create index? I don't know, not just like plain by number 1 to 3, but like more, I don't know, in a more organized way to say like per topic or something like that. That you kind of like optimize the read performance afterwards.
Yeah. So yeah, there's a number of issues that you are hinting at that I didn't investigate yet, but we have primary key, which is artificial, so it's numbering, which is of course automatically there's an index on that, and also we have index on timestamps. So yeah, I have timestamps with that. Yeah. So I know that previously there was some previous work with this Rosbag2 storage evaluation, where there are 2 table architectures, two database architectures. So architecture is a big name, but one has a foreign key, so there is like you have this key and the topic name and perhaps description, and then you have only the data, the blobs of data in the other one with timestamps. But as I ran those packages in different circumstances, one or the other is better. So it's not very clear. But of course, these things matter. There's a lot of room to look for optimization still. What I'm presenting here is just the top, so low-hanging fruits, I would say. The things that we can take now and improve by much, and then it's still a great idea to investigate things like what you are describing, Karsten.
Yeah, that makes sense. And the performance benchmarking tests here that you have to help us plot that information will give us confidence about future tests.
Exactly. So I hope this will be useful, and over changes in performance, we will get better and better scores and some confidence that this is what it is.
Great. Well, I don't have any more questions off the top of my head right now. Does anyone else on the call?
So Dan here. My question is now more of a logistics nature. So basically, my personal problem is that our customers actually cannot work with this tool the way it is. So it's basically too much performance hit, too much data losses, and then sometimes even random other errors. So we would actually need a fix like this within maximum 3 months. I see now 2 possible scenarios there for I think our problem, but I think that's actually a problem of many other people also that are seriously using ROS2, which is either here the working group in the community very prioritizes this and gets it fixed according to to Adam's suggestions, or we, and here there could be two ways, as a community, sponsor Adam and his little service company to actually let him implement it. The benefit of the second approach would be that he's now delved into this a lot and actually has expertise in SQLite, which I understand, at least in this group here, not many people have.
I don't know if we can come to a decision right now. I think that we definitely have a priority because we also have customers that can't use Rosbag2 right now because of performance issues. So we're also looking into allocating resources to this. I don't think our time frame is quite as quick as yours, but maybe this is something we need to discuss as a follow-up of how we want to get people working on this. I think that we can't make any promises right now, but I think that we could allocate some of our development into this over the next few months, but at least from my immediate team. But I doubt that we could handle all of it ourselves. So maybe we want to send out a call for, especially because I feel like we have well-defined tasks here. We could send out a call to the community and see if anyone wants to pick it up. That might be useful. Sponsoring is a little bit harder to pull. That's a more complicated situation. Not that it's impossible, but
okay. So will you then send out the call?
Yeah, sure. I'll start a new
I
thread
mean,
on this.
the two things which I think we can tackle immediately. One is the threaded consumer producer. I mean, that should be. I'm not saying it's fairly trivial, but like it should be at least straightforward to know what to do. The other thing is like I actually feel, you know, what Adam also said, like we should just change the default values, the pragma settings in SQLite. What I'm hearing here is like if the only reason when stuff goes really bad is that if your actual OS crashes, then I think it makes sense to have them as a default and then later on come up with a somewhat like, you know, XML or YAML configuration per storage, which lets you override these values.
Yeah, I think that we could allow the SQLite storage plugin to expose its own option or something such that you could provide a storage specific configuration. Right. It feels like that makes sense. You know, if we're going to have underlying implementations that have lots of configurability, we might as well let them expose the ability to configure them specifically. But yeah, we can change the defaults to start out with. That sounds fairly trivial. So it sounds like we have a few.
I mean, you can reach out to your customers here, but like maybe that, you know, is like achievable in a fairly timely manner, and so maybe that will actually just like, you know, at least satisfy your customers to a small or like to a little extent, so that they don't lose hope.
show progress quickly, and then we can figure out what's still a problem after we take care of these low-hanging fruit, because it seems like we get a lot better performance with a few small changes, and then it might be a more difficult battle from there, but maybe it starts to meet the needs better.
Yeah, luckily this is the case here. It seems like we really need to do only very little work to get a lot. And it's often, when you first measure performance of something, that's often the case. You get some things really cheaply, and then you have to work for your gains. Yeah. So just a note to what Carsten said. I didn't test a lot of this mixed settings, so journal mode right ahead and synchronous off. As you mentioned, Carsten, if the problem is only OS crash, then we should just change the default, but that's only in the case of synchronous off. But in case of journal mode memory setting, this can also corrupt in case of application crash. That's how it's stated in SQLite. I also didn't test it, and I think some crash testing would be nice to determine that. But yeah, changing synchronous to off and testing whether that works. I ran like maybe 10 tests of that. But as you've seen in the report, that's not the case we tested. We tested both optimizations together. I only tested this mixed case to understand which one affects the performance more.
Okay, yeah, well, I think that in a PR where we change the default, we can run the performance tests and compare before and after and just show the documentation that says, this will only be a problem on OS crash, and we can note that in the Rosbag2 documentation. So as long as we get performance gains there, I think it'll be valuable. So the actual code work will be less than the work to prove that it's a good idea, but we've got a lot of the tools in place now, so. Still working on reviewing through all of the code. It's a pretty big one, but it seems like it'll be useful. And since it's not part of the functionality, it doesn't need to be as strict in or to putting it in.
Hey, Emerson, will you also then organize the issues in the tracker?
Yes. So we're definitely, that's one of the things we want to do for this working group going forward is have the primary responsibility be really carefully organizing and presenting issues to the community, especially since we can't always promise to have development work. At the very least, we can provide a very organized backlog. So I'm going to take that down as an action item on the meeting notes. Send out call for contribution, not call for help. That sounds a little desperate. For issues, and then clearly performance tickets in backlog. Yeah, so next week's meeting will be at the same time, and we're going to be focusing on the backlog that time. And before then, I'll get these issues on there in some place, but that's going to be one of the big focuses next week. So,
perfect. I actually have one other question for, I guess, everybody here. Is anybody working with RTI's DDS implementations?
Not on our side. Sounds like a.
I only had brief experience, yes.
Yeah, so our additional problem related to here recording is that they apparently are not giving the access to the raw to the serialized CDR format, which basically means that for us to record, we need to get the message, serialize it into a DDS sample, and then deserialize it into DDS sample, and then serialize it into the CDR again, which.
Oh, so if you want to use Rosbag, you have to do a round trip serialization on top of recording. So that adds a lot of CPU overhead then, I'm guessing.
Yeah, I for some reason just recently actually Carsten pointed out to that, and then I realized that that's horribly how we're doing it. Okay, but it's our problem.
Yeah, unfortunately, we haven't spent any time with Connext other than just trying to expose some of its QoS features at one point.
Got it.
Okay, thanks everyone for coming today. We're out of time. I think this was a successful breakout session. I would like to try the pattern again for some more different topics. Maybe we can even come back to this with a follow-up once we've got some of these implemented. Yeah, so I'll see you all the next time. Have a good Friday or Saturday.
Thank you, everybody.
See you next week.
Thanks, Adam.
Yeah, thanks, Adam, so much. It was good
This
presentation.
was really
So
awesome.
useful.
Great
Yeah.
presentation.
Thank you.